In section 4.8, we have triangles or are isosceles and equilateral triangles. And as you already know, an isosceles triangle, it's a triangle that has at least two congruent sides. Can an equilateral be an isosceles? And the answer is yes. Okay, so there's a theorem for isosceles triangles. And the theorem says, in an isosceles triangle theorem, if two sides of the triangle are congruent, then the angles opposite to the sides are also congruent. So if you have two sides given as congruent, then the opposite angles, in this case angle T opposite to that side and angle S opposite to TR, they're also congruent. And then the converse of the isosceles triangle theorem, the converse says if the angles are congruent, then the sides opposite to those angles are also congruent. So with that fact, let's go ahead and follow the example. In the example, it says find the measurement of E in the triangle DEF. So if you want to find the measurement of E, well, since they're giving you the tick marks, you know that they're equal. So the base angles are equal to each other. So you let them equal to each other. Find the X. Go back to angle E, plug it in, and then you find the answer. So let's apply that into the examples 1 through 4. Number 1, the measurement of angle B is 78, and this is an isosceles triangle. So what do we know about angle A and C? They will be what? They will be the same. They will be congruent. So these two angles are congruent. Any ideas on how to find the measurements of A and C, Roman? Okay. It's okay. So 180, that's okay. 78. And what did you get from that? 102. And what do I do after I get the 102? Thank you, Joseph. Divided by? By 2. Thank you, Joseph. Anyways. So half of 102, and that would be 51. So the measurement of angle C is 51 degrees. Great. What about angle 2? Would that be the same thing? Yes, go ahead and work it out. So the answer for number 2 is 47. How did you get the 47?
Just check 86 from 180 divided.
And was that 94? So you got 47 as the answer? Great. Everybody okay with that? Great. Okay. Now for number 3, this is just like the example that they gave us. They're saying that it's an isosceles. Therefore, the angles are congruent. The base angles are congruent. So angle H is congruent to angle J, which means that 8x, the angles are equal by definition. 8x equals to 6x plus 18. What's the next step after that to solve for x? You just subtract 6x, that's right, from both sides. By 2. So x is 9. And once you know that x is equal to 9, they want the measurement of angle H.
8 times 9 is 72.
You plug it in, 8 times 9, and that is 72. Good job. And then we do the same thing with number 4. Go ahead and try number 4, please. Okay, the answer for x first is what?
30.
Is 30 when you solve for x. And then you plug it in, and that would be 60. That is right. 30 plus 30, which is 60. Awesome. Okay, let's move on to the next side, which is to the right side. Okay. So on the right side is talking about equilateral triangles. And in equilateral triangles, it says, the corollary says if a triangle is equilateral, then it is equiangular. So if it's equilateral, it would be a fact that it would be equiangular. Same sides, so all the angles are also congruent. And the equiangular triangle corollary says the other way, you know, the converse of that. If the triangle is equiangular, then it's equilateral. So on the example, it says you can use these theorems to find the values of equilateral triangles. Here, they're only giving you one angle. They're saying angle V is 7x plus 4. But what do we know about this triangle if they're saying that it's an equilateral triangle? What do we know about angle V? Would that be the same as the other angles? That is true. And how much is that? Do any of you know how much that is? 180 divided by 3 equal angles. 60. So every time you have an equilateral triangle, each one of the angles is going to be 60 degrees. So with that fact, you can just say, well, 7x plus 4 equal to 60. X is 8. And that's what they wanted. What is x? X is equal to 8. So on the examples, let's go ahead and go over the examples. Number 5. What can we say about angle R in number 5?
You can divide 5 by.
The measurement of angle R is, first, how much is that equals to? 60, because it's an equilateral triangle. And then you said what?
You can divide 5
Uh-huh.
by 60.
Into 60?
Yeah.
That's right. So n by itself is 60 divided by 5, which is 12. And that's what they want, the measurement of n, which is 12 degrees. Great. And then we'll do the same thing with number 6. So go ahead and find the value of x in problem number 6. What's the answer for x? Just give me the value of x in number 6. X is 33. Do all of you have 33 also? Yes? Okay. And then x is equal to 33 degrees. What did you to get the 33? What's the equation?
2x minus 6 equals 60.
Equal to 60. And then
And 6.
add 6. And that gives you 66. Good. And that is 33. Awesome. Thank you, Joseph. Okay, next problem number 7. In problem number 7, this is a little different because now it's not talking about the angles, it's talking about the sides. So it's pretty much the same idea. It's an equilateral triangle, therefore, it's an equiangular. So by the corollary, we can say that it's also equilateral. So since it's equilateral, we can let the sides that are given equal to each other. So here, 9r equals 5r plus 8. And then we solve for r. This is minus 5r. Subtract 5r to 9r. And that is 4r equals 8. Divide by 4, which is 2. And then they want VT. And VT is 5r, but r is 2. So that would be 10 plus 8, which is 18. Great. Okay, go ahead and try problem number 8. Do you set up the equation already?
Yes.
What did you set up as the equation?
I don't know how to do this.
This is an equiangular, right? Which by the corollary is also what? If it's equiangular, if all the angles are the same, then
The bottom is
all the sides would be the same. All the sides would be congruent, okay? So if all the sides are congruent, then what would be the equation, Matthew, that you can use?
y plus 10 is equal to 4y plus 1.
That's it. Y plus 10 equals to 4y plus 1. And what did you move first, Matthew? What did you move first?
The y.
The 1y? And how much is 4y minus 1y? 3y? 3y. And what's the next step?
Subtract
1. And 10 minus 1 is? And last step?
divide by 3.
By 3. And 9 divided by 3 is? 3. Okay, so then they want me to find mn. mn, and it doesn't really matter which I choose because it's an equilateral, they're all the same, right? But they want mn, so it would be 4 times 3 plus 1. So how much is that?
13.
And the answer is 13. Good. Any questions on equilateral triangles? No? Okay. On the back side, you have the assignment. Let me go over one problem. And that one problem that I'm going to go over, just so that you can have an idea on what to do, how to approach it. This is problem number 9, okay? In problem number 9. In number 9, we have a straight line, and then we have a triangle that has tick marks like that. What is that supposed to mean? Equilateral. So if it's equilateral, all the angles are what? Equal, congruent. And how much is each one of the angles in that triangle? 60. Okay, so then that's going to be 60, and each one of those angles is 60. Now you have an isosceles triangle. What can you say about the linear pair that you have here? How much is the other angle supposed to be?
120.
120. So that angle is 120. Okay, so if I want to know the measurements of the other base angles, subtract that 120 from 180. That is right.
60, you divide that
By 2, and that would be
30.
30. That's right. So each one of these angles is going to be 30. And they want one of those angles, which is angle A, and that would be 30. Okay, so just in case you have something like that, just approach it from the side that you know, and then just continue from there. Okay? And number 10. Problem number 10. In number 10, you have two triangles. Let me start with one of them. This is an isosceles triangle, and the vertex angle is 102. What would be the measurement of angle T and the angle RST? What is the measurement of that angle? Angle T and SRT. Any ideas on how to find those angles? 36, subtract 102, that is,
39 minus.
it would be 39? Yeah, 39. That's pretty good. That was pretty good. That was close. 39. We got that. Now, let's go ahead and Mario. What about in the other triangle? What should I do to get the measurement of the other angle in the other triangle, which is this one here? How do I get that angle?
You add them 39 and 3. Or you
I had 39 and 3.
can
I'll take
How come that one has a double tick mark?
102.
That is a good point. This one is saying that these are congruent, these sides are congruent.
You?
Oh, I didn't
So my
see
question was, how did you get the measurement of that angle?
Oh, what angle?
This one here,
Which one?
the one that I'm pointing to,
Oh, that one.
right? The angle
I thought it was
ORP.
congruent. I thought it was congruent to the
It would be
the RS.
congruent if the vertex angles are congruent. But notice that angle S is not the same as angle O. So I cannot conclude that. But sure, I can approach it the same way I did approach this one,
More
right?
than 180 minus 76.
There you go. 180 minus 76. That is 104.
Divided by 2 is 52.
Divide that by 2, and that is 52. Okay, so this is 52. 52. And the thing here is that they're asking you for x. So any ideas on how to find the measurement of x? Raise up your hand.
That's
Okay.
straight.
What is that?
The circle equals 360 degrees, you add 52 and 39, and you divide by 2.
Okay, the circle is 360 degrees. You add 52 and 39.
And 20.
You know that this half of the circle is 180, isn't it? Okay.
You add both of
You
those
add those
angles
two.
and then you do.
Okay, Joseph, you add those two, 52, 39, and what else?
You subtract that. No, you subtract that
From what?
from
From 180. That's right. So we don't really subtract from 360, but it's only 180 because it's half of the circle. It's the straight line, 180. So 91, which is 52 plus 39, subtract from 180, and that is what? 89. So x equals 89 degrees. So for something like this, you have to find out the two angles to find out what they're asking for. So in some cases, you're gonna have to do something like that, okay? Good job, all of you. Any questions about all these problems? So far, so good? Okay, so I'm gonna give you a chance to work on one of the two sides, either the left or the right. If you complete one of the two sides, show me the work and I'll stamp it so you can get 10 extra points, okay?